Alright guys, in this video we're going to be talking a little bit more about stoichiometry, we're going to be looking a little bit more in depth with what is known as empirical formulas. Now, empirical formulas are the simplest ratio possible of the elements that are found in a compound. Now, to illustrate what I mean by that is we know that blood sugar, also known as glucose, has the formula C6H12O6. However, upon further analysis, if we look very carefully, we see a common multiple of 6 in all three elements of glucose. So when we do that and we take out 6 from each element, we get a formula of CH2O. And that's exactly what the empirical formula is. It's the ratio of the number of moles to each element in a particular molecular formula. Alright? So, when it comes to doing empirical formula problems, what's going to happen is we're going to follow a series of steps that allows us to go from grams to moles, compare the molar ratios, and find a formula. Alright? So, for example, what we'll do is we'll look at ascorbic acid, which is also known as vitamin C, contains a percent composition of 40.92% carbon, 4.5% hydrogen, 54.50% oxygen, and it wants us to determine the molecular formula. Now, there's going to be three main steps that we take for these empirical formula problems, and here is what they are. The first is to convert to moles of all of the elements that you have. If you're given a percent composition of the sample, assume it is a 100 gram sample. The second one that you're going to do after you determine the number of moles is take the smallest amount of moles and divide each element's subscript by that number of moles. Lastly, and this one gets a little tricky sometimes, is if you have a subscript that ends with a fraction or has a fraction in it, you're going to multiply it by a whole number to eliminate fractions as subscripts. And we're going to do an example of this to illustrate what that means. So let's look at this ascorbic acid example. So the first thing we want to do is, well, we'll write our composition. So we have a carbon is equal to 40.92%. Hydrogen is equal to 4.5%, 4.58%, sorry. And oxygen is equal to 50.50%. Okay? Now, as I said, this is a percent composition. We can assume a 100 gram sample. That's step one. Okay, so considering that this is a 100 gram sample, we can just convert the percentages directly to grams. So, use colors here. We have 40.92 grams of carbon. We have 4.58 grams of hydrogen. And we have 50.50. Oh, I'm sorry, this is 54.50. 54.50 grams oxygen. That's the first step. Okay. Well, it's part A of the first step. Now what we're going to do is we're going to convert these values to the moles of each element. Okay. And again, guys, I cannot stress enough, please use your units. You're going to notice that it's going to be really helpful in the cleanup of all of these empirical formulas and stoichiometry problems. So 40.92 grams we're going to convert to moles. that's going to give us 3.47. And last but not least, let's convert the grams of oxygen to moles as well. Okay. Now that we've converted to moles, we can look at number 2. Determine the simplest whole number ratio of these moles by dividing by the smallest number of moles of the 3 elements. So upon analysis, we see that the lowest number of moles is 3.406, which is the moles of oxygen. Okay. So what we're going to do now is divide by the smallest whole number. So we have 3.407 divided by 3.406. We have 4.54. Okay, so when we do this, we get that C is equal to 1, about 1. And remember, if it rounds to whole numbers, that's a good thing. Then we get 4.54 divided by 3.406, which is about 1.33. And last but not least, we get 3.406 moles of oxygen over itself, which is 1. Now, we see a problem here, because we have a fraction in the moles of hydrogen. However, we can combat that. Recall that this reciprocal of a fraction is a whole number. So if I have 1 and 1/3, what I can do is I can multiply everything by the reciprocal of 1/3, and I can cancel out the fractions. So here's what I'll do. I'll take the molecular form, or the empirical formula that I have right now, which is C1H1.3301, and I will multiply everything by 3. Okay. Clean this up a little bit. C1 H1.3301. So now I'm going to multiply by 3 to cancel out this hydrogen. But I'm using the distributive property here. So I will get C3 H1, oh sorry, H4 O3. And that is my empirical formula. Okay. I realize that these are very, very involved, so I will be doing more examples of these, but I wanted to introduce them to you guys and show you the breakdown. They do follow all of the same steps. Again, the first step is just figuring out if it's a percent composition or a gram sample. You're converting to moles. The second step is finding the smallest molar ratio, which is determined by taking your smallest number of moles and dividing all of your element moles by it. And then if you run into a fraction, getting rid of the fraction by reciprocating it by multiplying by the inverse of it. So if it's 1/3, you multiply by 3. If it's 1/5, you multiply by 5. Okay? If you guys have any questions or concerns, please do not hesitate to comment or message me, okay? Thanks for watching, guys.